Hey everyone, let's do another projectile motion problem. This one's going to be a little different than the last one. But what we have is a skier comes down a slope, hits a flat region on the slope, and then launches off of the edge of this hill at 30 meters per second. And I'm going to make it horizontal, so the 30 meters per second is strictly in the x direction. And so I can say that V naught equals 30 meters per second purely in the I hat direction. Okay, it's just in the x direction. But then she comes off of the slope and she's going to follow a parabolic path until she reaches the edge of the hill. And what I'm interested in is, where does that take place? Right? Where does that take place? So a couple of things. First off, let's look at the position as a function of time for the skier. So her x position is equal to x naught, but that's the initial position. So let's go ahead and set this equal to the x-axis, and we'll set right there equal to the y-axis, and that's going to be a really good move for us. We'll see here in a minute. So her initial position as she leaves the slope is 0, so that's taken care of. So it's going to equal 30 meters per second. That's her initial x velocity times time plus 1/2 at squared, but there is no acceleration, right? Not in the x direction. So that's it. 30 meters per second times t. The y value is equal to y0. Again, that's at the origin, so that's equal to 0, plus the initial velocity she has in the y direction, but she has no y velocity. It's purely x. So that's 0. Minus 1/2 gt squared. So I'm going to say minus 1/2 gt squared. I'm going to make my life simple and say that g, acceleration due to gravity, is 10 meters per second squared. I just want to make it nice. It's easier to work with this way. But you can put 9.8 in if you want, or 32.2 feet per second squared if you want. That's fine. So that's going to be minus 5 meters per second squared t. So there's the x position and the y position. All right, but I have no idea what t is. So how do I solve this? I've got too many unknowns. So what's going to happen is the skier follows a parabolic path until she intersects with the hill. So I can get this if I know what the equation is for the hill. All right, well, that's just y equals mx plus b. It's a straight line. Now, it could be that it's not a straight line. It could be parabolic or cubic or sine function or something else. But in this particular example, I'm using a straight line. The y-intercept is 0 because it's at the origin, so that's nice. M is the slope. Slope is rise over run. But the rise over run is the tangent of the angle. When you think about it, we talk about tangent to a curve. Tangent is slope. That's where that tangent's coming from, right? This is all a slope. So the rise is the change in the y position. The run is the change in the x position. So this is just equal to the tangent of 30 degrees times x. It's negative, so I want to put a minus sign in there. So y is equal to minus tangent 30 degrees times x. And so what do I have now? I've got one equation here, one equation here, and another equation here. I have 3 equations, right? But I've got, as unknowns, I have x, y, and t. So I have 3 equations and 3 unknowns. And we can solve for that system of equations, right? So I could put y equals minus tangent 30x. I could put that in here. X equals 30 meters per second t. So I could write something like minus tangent 30 degrees times x equals minus 1/2, well, not the 1/2's already in there, minus 5 meters per second squared t squared. Right, that should be a t squared. But x is equal to 30 meters per second t. So I have minus tangent 30 degrees, 30 meters per second t equals minus 5, that minus 5 meters per second squared t squared. So one of the solutions here is that t is equal to 0. What is this telling me? This is when the skier is at a point on the slope. Well, that's right here. Right, so there's 2 points. There's one right here, and there's one right there. And these are where the skier position equals the line position. That's physically what's happening here, right? The skier's on the line. So the skier's function intersects the line. Well, one of those points is here. That's t is equal to 0. And then the other one, if I divide by 5 meters per second squared, the minus signs go away. And I divide by a t, because I've already got that one. So t is equal to 6 seconds. Divide by meters per second squared. Let's do that. 30 meters per second divided by 5 meters per second squared. That's going to be 6 meters per second divided by meters per second squared, same as times seconds squared over meters. The meters go away, 1 seconds go away, and I get 6 seconds. Let's not forget the tangent of 30 degrees. Whatever that number is, I don't care. Right? But that's the time. And so now I want to know the position. I substitute that into x, figure out what x is, right, based on that. So 6 seconds tangent 30. So I'm going to get 180 meters times the tangent of 30. There's my x position. And then substitute that into here, and I get my y position. And that's how we'll find the final position in those scenarios. You guys can do the calculations as easily as I can, but you'll get your final answer that way. All right. Any questions on this? Please leave them in the comments, and I will get back to you as soon as I can. Thank you.